All right. I'm doing okay on time, so I might go through this quickly, but we're going to share these slides because this is some practical hints on switching rates and filterings. So for a power measurement, I'd say have your sample rate about 10x your switching frequency to get that switching information. You want that for the power, but you don't need all the super high frequency details because no power transmits in that. You wanna have the bandwidth of interest. Filter 2 times above your highest harmonic of interest. Because electrical power, again, this is all for power. Electrical power is carried in the fundamental and its harmonics. If your highest harmonic of interest is the 20th harmonic, take your highest speed times 20 times 2, and you'll have a pretty good measurement. But please note, current sensors are the limiting bandwidth, so don't set your filter above your current sensor. There's no point. Consider the bandwidth you want for your calculations, for your power, for your fundamentals, for your P, Q, S, RMS. Consider your measurement uncertainty. Don't try to calculate things that are impossible. If somebody asks you to calculate iron losses, really sit down and say, hey, instruments aren't that accurate most of the time. And use the same filters on all channels. And this is a big mistake that people make. Set everything the same. Voltage, current, DC, AC, all your filters the same. That'll help a good measurement quality. Now, for you test guys, once you start asking these questions, you need to start asking your engineers some questions to get the good measurement. So don't be afraid to ask your engineer, what's your switching rate? So you can go back to my slide before and give some good advice. What's the bandwidth you operate your models at? That'll help you have consistency between MATLAB and measurement. What's the bandwidth of interest for those different signals? Power, RMS, Q. What's your max fundamental frequency? And don't be surprised if your engineers give you conflicting information. Ask more questions. Dig into this because everybody might learn about measurement and we might get to some really consistent good results faster. So once we've solved the EMC issues, we can say, all right, we don't need to filter the hell out of our signals anymore. Let's get to good measurements, good calculations. Here's a super practical. You guys can read that on your own.